3. Composition function. Composition function, that means you combine the two functions together. Now, suppose we have function y equals fx. We also have another function gx. Now, we use gx as a variable of fx. Then this equation, this function, we can write like f(gx). So, suppose we have a function y equals fx, okay? Then we have another function, it's y equals gx. Then we can use this function as a variable of this function. Get a function is f gx. This one called combine of composition of f and g. So we can use this sign to represent h equals f combined with g. This hx actually you can write f gx. See, this one looks very hard to understand, right? Now let's see an example. Then you can see very clearly. Okay. Let's say the example 16.10. Suppose we have function fx equals 2x minus 6, gx equals 3x minus 9. Now we try to find, let's first find what this one means. Everybody, can you calculate this? Then send me your answer here. What's your answer for this? See this one first, can you find the g2? When x equals 2, prog to gx, then find what is g2? After you got g2, g2 is a number, right? Then you prog to here. Use that number, prog to f, then you got a value for f. That value, that's what we are looking for, right? Now, let's say here, 2. Yeah, Emily, you got it correct.
Okay.
Who else? Now only Emily is sending me the answer that's correct. So first, you need to calculate what is the G2. Okay, this is the function gx. So when x equals 2, G2 equals 3 times 2 minus 9. Okay, this one will equal 6 minus 9 equals negative 3, right? Then you calculate f G2. So this one will equals f negative 3. So you plug x equals negative 3 to this equation. You can see here that's negative 6 minus 6. So you got this one equals negative 12. Okay, good. Now let's calculate G F2. Everybody send me an answer for this. This one definitely you need to first calculate what is f2. Okay, Emily, correct. Very good. Who else? This one first, oh, Jerry, correct, very good. First, you need to calculate what is f2. f2, you got 2 times 2, 4 minus 6, you got a negative 2, right? Then you calculate g f2. Then you know f2 that's equals negative 2, g negative 2, that's equal to here. Negative 2 times 3, that's negative 6. Negative 6 minus 9, you got negative 15. So correct answer is negative 15. Okay, and let's say it's tau. If tau, you got it not right. Good try. So now let's say everybody calculate this. What is this one equals? So here gx now it's a variable of fx. So that means you need to use 3x minus 9 to replace x in the fx. Then simplify. See what you get. Okay, now let's see. Yeah, Emily, correct. Who else? Now, see this one you need to do 2. Here, use 3x minus 9 to replace this x, then minus 6. Then you simplify this, you expand it, you got 6x minus 18, then minus 6. So you got this one equals 6x minus 24. Okay, this one's correct. Okay. Bob, you're also correct. Very good. Bob is also correct. Now let's see who else. Only Emily and Bob got it correct. Okay, so from this one you can say just combine the two functions together. This sign just combine. You know, if we put gx here, that means gx is a variable of fx. You need to use the expression of gx to replace x in fx. Then simplify. That will be your result. Okay, now let's see another example. Suppose fx being the function 3x plus 10. Then they ask you what value of x does f(x) equals x. Okay, what is this one equals x? Everybody do this. Say they give you this fx is 3x plus 10. Then they ask you what is x make this one equals x. What value of x does this one equals x? How to do this? I suggest you do step by step. Don't be scared. First, you need to understand what this one is. See, this one that's fx, it's a variable of fx. So this function fx, that's 3x plus 10. So that means here, you need to use fx to replace this x. Fx, that's 3x plus 10. So that means you need to do 3 times 3x plus 10, then plus 10. This one equals x. Now expanded, you got 9x plus 30, then plus 10 equals x. Then you get 9x plus 40 equals x.
Excuse me?
Yes?
I don't understand how you got 3 times 3x plus 10.
Yeah, you don't understand this. Okay. See, here, because they put this one here, right? You know, the fx, this one equals 3x plus 10, right? Now this variable is x, right? For the original fx variable, this one's x. Now this one said the variable is fx, so that means you need to replace fx to use fx to replace x, right? If you do this, say the left side, that's exactly what we are looking for, right? So the right side will be 3 times fx, then plus 10. Fx equals 3x plus 10, right?
Oh, I see.
Got it?
Yeah, I think I got it. Yeah.
Okay.
Look at it. So.
Then you keep simplify. Here you can get 8x, both sides minus x. 8x equals negative 40. Then both sides divided by 8. You get x equals negative 5.
But then I got f times 3x plus 10 equals the x.
Did you get this?
I half of it. Like, I don't know how to get the 3 and the 10 at the outside the parentheses.
Yeah, if you got this one now, that will be almost, you're almost successful. So then you just distribute this 3 here. You got a 9x plus 30, then plus 10 equals x.
After I put it in, I got f equals f times 3x plus 10 equals the x.
Okay. So then you simplify. So first, Paul, can you write down what is the first equation you get here? Can you write down your equation here?
Okay, so
if you got this, did you get this?
Yeah, well, kind of. I got like the 3x plus 10 in parentheses, but I didn't get the 3 on the outside and the 10 on the outside.
You need to add 10. You know, here use fx, you can only replace this x plus 10 is still there. You need to copy this part also down. If you don't have this part, definitely your equation is wrong. Because here fx to replace x, there are other parts you still need to keep same. Okay? So first, you need to get this equation. If you did not get this equation, your answer definitely will not right.
So
if you got this, start from here, that's just a simple algebra. Simplify, then solve. You got x equals negative 5. So Bob got a good job. Bob, your answer is right. Okay, so this one is actually it's hard, okay? But don't be scared, okay? Now we will do more practice, then you will understand more, okay? Now let's see this one. Here they give you fx equals 3 minus 2x. And they said g fx equals this. Then A, why is g7 not equals this? B, for what value of k is fk equals 7? Then they ask you to find g7. Okay, so fx equals this, gfx equals this. So then we need to find what is the gx. To do that, we need to combine some function here. Now let's see. We can do, see what we can do here. We can do, they ask you to find G7. G7 is not equals, yeah, that's x equal, when x equals 7, you got this value, that's for x. But when x equals 7, then what is, we need to find the fx equals 7. So first, you need to do this. 3 minus 2x, set this one equals 7. Okay? Because here we try to, if you're trying to find the G7, you need to make this fx equals 7. Right? So fx equals 7, that means 3 minus 2x equals 7. So then you solve x. From here, you can get 2x equals negative 4, right? So then you can get x equals negative 2. Then you plug to here. When x equals negative 2, you got this one's 2, then negative 2 cubed minus 3 times negative 2, then plus 5. So we got this one will equals negative 16 plus 6 plus 5. So got this one equals negative 5. Okay? So then that means we get G7. This one actually is G7. You know, here, you know, when the x equals negative 2, fx will equal 7. So here, actually, we plug 7 is here. Fx equals 7. But x equals negative 2. You plug x equals negative 2 here. You got a G7 actually equals negative 5. Then they ask you to find what is the value of k for fk equals 7. Fk equals 7, that means k here actually got this k equals negative 2. Right? When k equals negative 2, 3 minus 2 times negative 2 will equal 7. Right? This one's the correct answer. So here, now let's see. We are looking for G7. Right? We are looking for G7. That means we need to plug fx equals 7. This one should equal 7. This one equals 7, that means 3 minus 2x equals 7. Because fx equals 3 minus 2x. So then we solve this equation, we get x equals negative 2. That means we need to plug negative 2 here to find G7. Okay, so you got G7 equals negative 5. Okay, now let's see next one. Suppose f and g are functions such that the range of g is part of domain of f, and h equals f combined with g. Explain why h is also a function. Okay, let's see here. Here, f and g are all functions such that the range of g. So if f is a function from its domain to its range, it's like this, right? Say g is also a function So this is the domain of f to range of f. This one is domain of g to range of g. Now they tell you that the range of g is part of f. So that means this set is included to Rf. So that means the range of g is smaller than the range of f. So I use this sign to represent Rg is included to Rf. Now they said if you do f combined with g, you got a new function that's h. This new function is also a function. Why this one is also a function? So that means you do this. This range of g is part of domain of f. What I hear that right? That's wrong. Okay, this one is part of domain, so that's belong to the df. Belong to df. So that means here, when we go here from the dg, domain of function g, to range of g, this range of g is also belong to domain of f. So then from the domain of f to range of f, so this one, like, we have two players. Okay, here the first one is g. G is from here to here. Then f, that's from here to here. So from here, this one is a domain of g, dg. Okay, so you can imagine this one is a domain of g. Then we got the range of g. Range of g belong to domain of f. Then from domain of f, we got the range of f. So they tell you this one is a function. Then after you get the value for g, that will be the variable of f. Now you can use this function to continue to reach here. So by this way, we get the project from the domain of g, first go to the range of g. Okay, you got this one. You can say this like machine. Okay, function, that's a machine, right? You go from dg to rg. Then rg it's belong to the df. Then df, that's project to rf, to the range of rf. This one's f, this one's g. So this one's a function. After you project this value, the project by rg to rf, that's another function. So this one, that's like chain, connect together. Because this one's a function. Then this one is another function. Combine these two, actually, that like chain, connect these two section, to segment together. Then you gotta combine these two functions, will be a function. That's the reason. Okay. Now let's see how they explain this one. So see here, To show that h is a function, we must show that there's only one value of ha for any valid input a. Because h equals f combined with g, we have ha equals fga. Therefore, any valid input to h must be in the domain of g. Because g is a function, there is only one possible value of ga. Suppose ga equals b, so that we have ha equals fga equals fb. Because f is a function, therefore only one possible value of fb. Since fa equals fb, we found that there's only one possible value of fa for each valid input a. In this equation, we start the range of g. It's part of the domain of f. Let's take a closer look at why it is important. Above, we let ga equals b, so b is in the range of g. Then we found that ha equals fb, so to evaluate ha, we must evaluate fb. We can only evaluate fb if b is in the domain of f. Yes. Similarly, we can only define h as f combined with g if each value in range of g is in the domain of f. That's exactly. Okay. So here, the key point is h. This is a combine of f and g. When you give an input for h, then you can only get only one output from h. If this one is true, that means h will be a function. This one will guaranteed from f and g are all functions. That's the reason then h also will be a function. Now let's go to next one. Next section, inverse function. Now let's say inverse function, that's you change the variable and x and y, change the position of x and y. So here, let's say suppose we have function y equals 2x minus 1, okay? Then you solve x in terms of y. That's you need to get both sides plus 1. You get a y plus 1 equals 2x, right? Then both sides divided by 2. You get x equals y plus 1 over 2, right? So this one tells you if we consider x, y as a variable, then x will be the function of y, right? So then we switch the x and y, because usually we use x to represent a variable, use y to represent a function. So then we switch the variable, we got this one, actually it's y equals x plus 1 over 2. So this one we call the inverse function of this one. If this one is original function, so first you solve x in terms of y. You know, if we don't switch the variable, these two functions actually exact same, right? But now we switch the variable. We only care about this relationship. Now we think y is a original variable, x is a function of y. Then that means we want to switch the variable. We got a y will equals x plus 1 over 2. Now this function called the inverse function of this one. So now let's draw. In geometry, what does this one means? If you draw origin Cartesian line, now let's see what does this one means. This function, these two are all linear function, right? So 2x plus minus 1, when x equals 0, y equals negative 1. Okay, suppose here is 0, here is negative 1. When x equals 0, y equals negative 1. Then when y equals 0, x will equals 1/2. So something is here. This 1/2. Then you can connect these 2 points. Okay. This one gives you the equation of y equals 2x minus 1, right? Now let's draw plot of this function. This function, you can say when x equals 0, y equals 1/2, okay, is here. When x equals 0, y equals 1/2. Y equals 1/2, it's here. When x equals 0, y equals 1/2. That's 1/2. Okay? It's 1/2. Then when y equals 0, if y equals 0, then x will equals negative 1. X will be here. Then you can draw the graph of this function will like this. Right? So now I can change the color. You can say this function will like this. Now let's draw where's the y equals x. So this one here, that will be, we can draw, say here. What do you see here? You can see the original function is symmetry with inverse function about y equals x, about this line, y equals x. Then the original function and inverse function, their symmetry. Their symmetry about y equals x line. Okay? So this is correct. This is always true. Now let's see here. Say this one. Actually, here it's a little bit difficult to understand. Say, if we use original function, we call that fx. Then the inverse function will be f negative 1. This one does not mean 1 over f, okay? This just means it's a special notation for denote the inverse of function f. Then now let's say function f and g are inverse functions and each other if and only if g f x equals x for all of a value of x in domain of x, domain of fx, and fgx equals x for all of the value of x in the domain of g. So then that means when you combine these two together, then you always get x. See the example I give you, suppose fx equals 2x minus 1, right? The another one is, suppose this one is fx. The gx suppose equals x plus 1 divided by 2. So now can you calculate what is the gfx? Everybody calculate this. See, what do you get this one? Gx, the variable changed to fx. Everybody calculate this. See, what do you get here? This one will equals, say, the variable will change to this. You replace this x. So that will be 2x minus 1. Then plus this 1, right? Then divided by 2. So this one, let's simplify. We got the x, right? We got x. 2x minus 1 plus 1. You got 2x. 2x divided by 2, you got an x. Then f gx. What is this one equals? Gx, that's equals this. Fx equals this. So you got a 2 times x plus 1 over 2. Then this one minus 1. So you multiply here, you got the x plus 1, then minus 1. So you got this one equals x. See, these two are all satisfied. So that means the inverse function of 2x minus 1, that's x plus 1 over 2. Okay, so now let's do some examples here. 6.14 give you fx equals 3x minus 2, gx equals x plus 2 parentheses divided by 3. So everybody calculate gf3. What is this one? What is gf6? What is gf10? Then in terms of x, what is gfx? In terms of x, what is the fgx? How are f and g related? Everybody do this. So let's see. First, to calculate this, you need to calculate f3. So f3 equals what? That's very easy. Just plug 3 here. 3 times 3, 9. 9 minus 2, 7. Then you calculate g f3. That means you need to plug 7 to here. So that's 7 plus 2 divided by 3. So you got this one equals 9 divided by 3, you got a 3. So that means this one, the value equals 3. So then they ask you to calculate this. Calculate this, you need to find the f6 first. f6 equals 3 times 6, that's 18. 18 minus 2, that's equals 16. Then g f6. This one will equals 16 plus 2 divided by 3. That's equals 18 divided by 3 equals 6, right? So that means the answer for this one equals 6. So what is this? That means you need to calculate f10. f10 equals what? f10 equals 3 times 10 minus 2 equals 28. Then you calculate gf10. This one will equals 28 plus 2 divided by 3. So this one you got a 10. So that means answer for this one, that's 10. Now in terms of x, what is gfx? Okay, to calculate this one, that's easy because this one fx, that means you need to use fx as a variable of gx. So that means we can get a 3x minus 2. This one to replace this x, then plus 2, then this one divided by 3. Right? Say combine of g and f, use fx as a variable of gx. Gx original variable, that's x. Now you need to use this one to replace this x. Then you say, actually I need to draw this direction should be like this. Use this one to replace this. So then you got 3x minus 2 divided by 2 plus 2 divided by 3. So open this parenthesis. You got here that 3x minus 2 plus 2 comes out. Then divided by 3, you got this one equals x. So actually this one equals x. Then in terms of x, what is the fgx? Okay, so then you calculate fgx. Fgx, that means gx is a variable of fx. This one is gx. This variable, that's x, so then we need to do 3 times x plus 2 divided by 3, then minus 2. So now that means 3 times this, got x plus 2 minus 2, so got this one equals x, right? So what you can see here, we got a g fx equals x. This one also equals x. So this one tells us what? These two functions are original and inverse function. So then now let's check if this one are related. Say fx, this one equals 3x minus 2. Gx, let's solve this one. Both sides plus 2. Now let's suppose this function is y equals 3x plus minus 2. Then we solve x in terms of y. Then get a y plus 2. Okay, divided by 3. That equals x. So then we write here this gx equals x plus 2 divided by 3. So then you can see here, this one actually is the inverse function of this. Right? If you solve x in terms of y, then you get this. So this one actually is gx. So that means this function is the inverse function of this. Therefore, when we calculate this one, should give you x. This one also gives you x. Because gx is the inverse function of fx. Now let's go to next one. 16.15. In this problem, we found the inverse of the function, this one. How to do this? Actually, I already showed you how to do this, okay? Let g be the inverse of y. Y must fgx equals x. Okay? So a function combined with an inverse function that will return to x. This one's true. You know why? Because, say, gx to suppose this is a domain of gx. They project through g. This one project their value to range of g. Now fx is reverse of g. Fx equals reverse function of g. Then you use g combined with inverse of g. That means just exactly project back. Okay? Then that's reason why f(gx) always equals x. So use the define of f to solve the equation fy to x for y. So that means you do this. You use y to replace x. You got fy equals 2y minus 9, right? So set this one equals x. Then you solve y. Y will equals 9 plus x divided by 2. Okay? This function actually will be the inverse function of gx. So here, this gx will equals x plus 9 over 2. Okay? Check your answer by check this. So now let's see. Gx, we got this, right? Fx, that's equal this. So you prog back 2x minus 9. Okay, this one plus 9, then divided by 2. This one will give you x. So that means this one is true. So that means what do we get here? It's the inverse function of fx. Okay, now let's see 16.16. The function f is the inverse of the function gx. Then they ask you find f4. f4, that's found the value f4. That's actually because f and g, the f is a reverse function of g. So that means you give this variable for f, that's actually the value for g. So that means you set g x equals 4, then solve x. This will, the x value will give you the value for f4. You solve this. Now let's do this. 4x plus 20 equals 2x minus 3. So then we got 2x equals negative 23. So that means x equals negative 23 over 2. So that means this one equals negative 23 over 2. Why? Because fx is a reverse function of gx. So the variable of fx, that number 4, actually is the value of gx. That's tell us gx equals 4. Gx equals 4, then we solve x. That's x will give us a value of, here this x will equals f4. You know why? Because gx, let's do this. Suppose g, this domain of g function, this one's the range of g function. Okay, suppose this one is this. Now we trying to, the f, that's a reverse function. This one equals inverse function of g. That's actually do exact same to this side. So f actually do this. Okay. So then you ask find suppose this one's 4. You ask find f4. So actually, that's ask exactly find this x value for g. So that means you set value of g equals 4, then solve x. That means you do this. Then the x value that will equals f4. Because this one's 4, then after the f function project, they will go here. That's here. That will be equals f4. Okay. That's the reason why we do this. Now let's see this example. This one is fx equals x squared, and let the domain of f be all real numbers. Does f has an inverse? In other words, is there a function of gx such that gfx equals x for all real numbers? Okay, so here fx equals x squared, and the domain of f be all real numbers. Does f have a reverse function? Okay, in other words, is there a function gx such that f gx equals x for real numbers? This one, everybody try to answer this problem. Yes or no? You can see here, if you try to draw a Cartesian plane, this one that's something like this. Okay, this one is y fx equals x squared. Fx equals x squared. You know, we know this one is a function, right? When you check, you draw the vertical line everywhere, you only get a one intersection for y. This one is a function. That's true. But now if you try to find the inverse function for this, is that inverse function exist? If you try to find the inverse function, that means you need to use y value of this function to project to the x value of this function. Then you can solve this one, say based on set this one, x equals y, then get this one equals y squared, then set this one equals x. Then you can solve this y equals square root of x, then plus minus, right? So you can say here, for any x, you get the two y values. So then that means when you draw a vertical line for this function, you get two different y values. This one is not satisfy the requirement of function. Okay, so that means this one is wrong. You cannot get this one has an inverse function. If you try to get that one, you need to limit it, the x value to the positive. X should be greater or equal to 0. Otherwise, you have two value for y. Okay, that's not true. B, suppose hx equals x squared, and let the domain of h be all non-negative numbers. Okay, say that's exactly, you limit x equals greater or equal to 0 to this part. Does h has a reverse? Definitely answer is yes. Then you get that reverse will like this. Okay, then there is symmetry about the y equals this one, this line is y equals x. So The reverse function is this one. The original function is this. So then the symmetry about y equals x. Because, say, if you limited domain of x is greater or equals 0, then we'll have x squared, y squared equals x, right? So then we solve y will equal root of x, because negative side is not satisfied. It's not in the domain of this function. So we can only keep the positive part. The negative part is not satisfied. So for this part, that's correct, right? So then now let's see, I want to summarize here. You know, for the composite function, actually it's very easy, okay? If you have a composite function fx, if you have the expression for this one, suppose this one equals 2x minus 1. Then you have another function gx. Gx, suppose this one equals 3x plus 2. Then if you combine this f with this g, do this way. This one means gx, it's a variable of fx. So that means you use 3x plus 2 to replace this x. Okay? So this way you get this one's 2 times 3x plus 2, then minus 1. So you simplify this, you get a 6x plus 3. But if you combine f with g like this way, so that means fx is a function, it's a fx is the variable of gx, so that means you do this. You use this one to replace this x. So you do 3 times 2x minus 1, then plus 2. So you get a 6x minus 1. So time is up. We can stop here. Then homework, that's all the exercise problem behind each section. So we can stop here. Bye.